Okay, students, we're on 12.4. So 12.4 is going to be about probability with permutations and combinations. So we're going to talk about how to find large amounts of possibilities of something happening. Okay, so an code at a high security building is a 3-digit number. So there's 1, 2, 3 digits of a number followed by 2 letters that are from A to F. Okay, so think about it. It could be like 1, 2, 3, A, B. It would be the security code, for instance. So I like to look at it as like, what are the different possible things that are happening here? What are we filling in? And so we've got 5 different things. So how many different codes are possible? So what I look at is I've got those 5 different things there. Okay, and there are 10 possible numbers, 0 through 9, to get there. Then there's 10 possible numbers here and 10 here. And what you're going to do is you're going to multiply each of these. So fundamental counting principle, just multiply each of them because there's 10 choices here times 10 there times 10 there times A through F, there's 6 choices times A through F. Again, there's 6 choices because it could be AA. Okay, so that comes out to 36,000 as a number of possible. Make sure we pay attention to this. How many different codes? We're thinking number of possible codes. Okay, if 2 letters are known, how many different codes are possible? So we have 1, 2, 3, 4, 5 things, but they know the 2 letters. So this is known and this is known. They're not chances anymore. Well, then we just have the 10 times 10 times 10, which is 1,000. 1,000 different chances that are happening there. Okay. What is probably that the first number of the code is a 0? So we've got 1, 2, 3, 4, 5 things, but all we care about is this first code being a 0. And there's 10 possible outcomes out of that, of what that code could be, and only one of them gives you the right one. Now, this is probability, so it's 1 out of 10. I don't care about everything else that's happening. I just care about that first one. So 1/10 would be that probability. Just to be clear, probabilities can be written as decimals, percents, and fractions, and so there's our fraction. What's the probability that any number in a code is 0? So any number in the code. So we have 1, 2, 3, 4, 5 again. We don't care about the letters. We care about the numbers. So here we have a 1 out of 10 chance that that's a 0. Okay. And then we have a 1 out of 10 chance here and a 1 out of 10 chance here. So a lot of people think we multiply those, but we don't. We add them because this is one thing that happens. Like we figure out the whole code and figure out that this is 1 out of 10. And then, so we have a 1/10 chance of it being there. Then we do it again with this one. And so we have a 1/10 chance of it being there too. So we have that added probability plus the same thing with the third one. And so we have a 3 out of 10 chance of you getting a 0 anywhere. Okay. So if you remember some of the code, okay, so this one, sorry. If you try to remember the code, but you can only record the 3 numbers. So we know the 3 numbers. Okay, those are locked in. What is the probability that you can get the rest of the code in one guess? So you have 6 chances here and 6 chances here. So it's 36 total chances and 1 right guess. So that would be your probability there. And if you can only remember the 2 letters, so we know the letter was probably that you can get it in one press. So you have 10 chances, 10 chances, 10 chances, which is 1,000. And there is 1 correct answer to this. So it's 1 out of 1,000. Okay, so that's a little bit of figuring out what we're going to do today. We're going to talk about permutations and combinations here today. So a permutation is an arrangement of objects in which order is important. That's going to be a big idea here. Okay, permutation, the order is important. One permutation for shuffling the songs on a 7-track playlist would be 5, then 7, then 1, then 2, then 6, then 4, then 3. Using the fundamental counting principle, there are 7 choices for the first song. Then once you've played the first song, then 6 choices for the next one. Once you've played those first 2, there's only 5 choices and so on, or 5,040. It's the expression 7 times 6 times 5 times 4 times 3 times 2 times 1 used to calculate the number of permutations of the 7 tracks can be written as 7 factorial. So your calculator, I'm going to be showing your calculator throughout here. Your calculator can do this. If you're on a calculator page, you can go to hit the number 7, and then right down here, you can see it in red right now. There's an exclamation point right there. And if you hit enter, it does 7 times 6 times 5 times 4 times 3 times 2 times 1. If you don't find that, you can also go into menu, go to probability, and you see factorial there, and it'll set it up as well with the same thing. Okay, so that's what 7 factorial is. The factorial of positive numbers is the product of the positive integer less than or equal to n and is written as n factorial. Really, all you need to know is if I asked you 3 factorial, that is 3 times 2 times 1, working all the way down. 100 factorial, I'm not going to write out, but you get the idea of it. Okay. Suppose you will listen to only 4 of the 7 shuffled tracks. Using the fundamental counting principle, the number of permutations of 4 tracks, the number of different ways to organize 4 tracks played from a 7-track list is 7 times 6 times 5 times 4, or 840. Okay. Another way of describing this, because you don't want to use a whole factorial, is as a permutation. Okay. So 7 tracks taken 4 at a time, denoted as 7p4. This number can also be computed using factorials too. But we can use this permutation idea. If I know that we're not repeating the orders, that the order is important, and going through this, your calculator can do this too. If you go to menu and you go to probability, you go to permutations, it's going to say NPR and open up parentheses, and you're going to put the 2 numbers in with a comma. So for this one, it was 7, and you were choosing 4 numbers. So of 7 numbers, so 7, commas down here at the bottom left, and then you put 4 in, and you hit enter, and it's going to give you that number that you're looking for there. Okay, so it's going to solve it for you. So you can understand and know this rule right here, or you can simply use your calculator to solve a permutation in that case. Okay, so the number of permutations of 7 objects taken 4 at a time essentially comes out to this: is you would do the factorial, but you would remove the last part of the factorial is the idea of that. Actually, this one's written wrong. And so then you would get your answer from that. Recall that the probability of an event is the ratio of the number of, favorable outcomes to the number of total outcomes. To find probabilities with permutations, the number of favorable outcomes and the number of total outcomes can be written as a permutation. So the number of distinguishable permutations of n objects in which one object is repeated r times, another is repeated r 2 times, and so on, is n factorial over r factorial, whatever, so on from there. We're going to do an example of this in a little bit, so we'll use that permutations with repetition. Okay, so 5 geometry students were asked to randomly choose a polygon, and sometimes permutations, combinations work. Sometimes it's easier to just work through the idea. So 5 geometry students are asked to randomly choose one of these polygons and describe its properties. So once you choose one, then it's going to go away. What's the probability that the first 3 students choose the hexagon, the pentagon, and the triangle in that order? Okay, so first 3 students is all I care about. And we want to know the probability that this first student chooses the hexagon. So here's my hexagon. They have a 1 in 5 chance of choosing it. There's 5 possibilities of what they choose, and you have a 1 in 5 chance of choosing that. Okay. Then once that student has chosen the hexagon, that's gone. My next student, I want to choose the pentagon. So here's the pentagon. They have a 1 in 4 chance of choosing the pentagon, and then that one's gone. And then my next student wants to choose the triangle. So the triangle is right here. You have a 1 in 3 chance of choosing that triangle. And so that's what that would be. And just like the fundamental counting principle, we could be just doing 5 times 4 times 3 and figuring out there's one possibility of this happening. But this is what you're doing. And if you multiply that, you get 20 times 3 is 60. And so you get a 1/60th probability of that occurring. Okay, I lost my mouse. There it is. So the next one is a spinning wheel. So the physics team is holding a game night fundraiser to win a grand prize in a particular game. You must spin the spinner 4 times and land on blue, red, green, and yellow in that order. What's the probability that you will spin the winning sequence? Okay, so we're talking about our winning sequence here. We're going to do a permutation of 12 factorial over, this is the repetition idea. So if we come back to this real quick, this is that idea of permutations with repetition. We've got to get rid of those repetitions. So what we're going to do here is that there's 12 different possibilities, so 12 factorial over, and then we're going to remove the repetition. So there are blue, so we're going to remove 3 factorial. There are green, we're going to remove 3 factorial, and there are 5 reds, we're going to remove 5 factorial. And that is going to come out to 110,880. And there is one possibility out of that. Now, some people are like, oh, no, there's more because there's more of these. But by removing those, we've already removed all of those possibilities in the beginning there. Okay. When outcomes are decided at random, they are equally likely to occur. So even though you might be like, no, you have a better chance of landing on red for some reason, we have to assume equally likely, okay, for each one of them. Okay, so permutations we had. Now combinations is a selection of objects in which order is not important. So we have to remember those 2 different ideas there. A combination of n objects taken r at a time is NCR, very similar to NPR. We can do this on our calculator. So if I do 7C3 here on my calculator, you pull up that calculator, I can go into menu, I can go to probability, and just go to, you have to choose permutation or combination. So if I choose combination, then I do 7, they picked 3 this time. So 7, 3, and hit enter, and I'm going to get that 35 that they give you here. Okay, again, you can memorize what you're doing with this, but you shouldn't have to know this because you're just going to use your calculator for that. Okay, but we do need to know order is not important in this case. So permutations and combinations when order of an arrangement is important and use combinations when order is not important. I like to think about a combination lock should actually be called a permutation lock. So when you do your locks, it matters the order that you put your numbers in. So it should actually be a permutation lock in that case. Okay, that is it.